Okay. So the next class we are going to discuss about atomicity and recovery. So in the acid properties itself, we have discussed about what is atomicity. No, so atomicity is nothing but when you have a bunch of transactions, you have to perform everything, or you should not start the transaction. So if you see here, if you have 10 transactions, if you started the transactions, you have to finish all this 10. Otherwise, you are not at all going to be started this, or you are not allowed to start. You have to finish it all or none. So atomicity is nothing but either all the operations of the transaction must be performed or none. So, and one more point is that whenever you are doing a transaction, there are two possibilities. One is to abort the transaction or to commit transaction. So in the last class only we have seen these two operations. So whenever a transaction is aborted, in the middle, so such kind of modifications are not going to be reflected in your database. So whatever the transaction are left in the middle of the transaction, such kind of data, for suppose a is equal to 100 ma, I'm going to increment it with the 100, but I'm not going to write it in the middle. Only I aborted the middle only I dropped in the middle. So this modification is not applicable, this modification is not going to be reflected in your database. So I left over in the middle so that a remains 100 only. This is not going to be reflected in the database. And the second possibility is to commit. Whatever the transaction have been committed successfully, only that results are shown in the output. So if you see, the modification done by the aborted transaction should not be visible to the database, and the modification done by the committed transaction should be visible in the database. So why? Because committed transactions will give you the accurate values. And next we have log and log records in this recovery. So why we have this log? By the way, what is log record and what is log? So whatever the operations you are going to perform on any account, whatever the operations, that is nothing but what are the amount you are going to credit, what are the amount you are going to debit, and what are the changes you are going to make, everything is going to be recorded. Who, when, what changes. So if you want to change your PIN, so that is also going to be maintained in a log record. Log record is nothing but whatever the actions you performed on a database, whatever the actions you have been done, everything is going to be recorded with the time. For suppose, now I have my phone pay, I want to change my PIN. I want to change my PIN number. So when you changed, who changed that PIN at what time? These data is called as log, where we are going to save that in log records. Okay. And basically we have three types of log records here. One is start, commit, abort. Start is nothing but whenever you started to commit something. Next, commit is nothing but where you are doing some operation, whether it is debiting, crediting, whatever, you are in the action. Abort is nothing but whatever the action you have been done, you want to leave from the transaction now. So these are the three records we have in the log. And also we have two operations. One is undo and second one is redo. See, because all the database modifications must be preceded by creation of the log records, the system has availability both the old value prior to modify the data item and new value that is to be written to the data item. That is nothing but see. Basically, we have two operations, undo and redo. Undo is nothing but using a log record set the data item specified in log record to old value. That is nothing but if a is equal to 100 and I am going to increment it with plus 100 rupees, but I am not going to write this, I am not going to write directly. I have some system failure, due to that I am not going to do this transaction. So this is a scenario happened in the middle. So what is your balance now? You are undoing this. You are undoing this initially your balance is A is equal to 100 only, because this particular action is failed. So you are undoing this whole operation, and your value is also going to be set back as 100 only. That is undo. Redo is nothing but the same operation. If A is equal to 100, I am going to increment it with plus 100 rupees. So now I have some system failure. Again, some system failure happened. I don't want to undo this. I want to redo this. Redo is nothing but I am trying it again to perform same action. Okay, I'm going to try it again to perform the same action. Up to when I will do? Up to when this A value is going to be changed as a new value. That is A is equal to 200. So up to when you are going to do the redo operations, I want to receive a new value to my log record. Appati varaku you have to redo the operation again and again until it is successful. If it is successful, we are going to abort the action. So basically, how many operations we have to perform? We have to perform two operations. One is undo and second one is redo. And see, there are two approaches to modify the database, that is dereferred modification technique, immediate modification technique. So why we are using this? So whatever the changes you are going to make to a transaction, sorry, what are the changes you are going to make to a database? So we have abort and we have commit transactions, no? So some kind of databases will accept partial results. So still you do not yet finished the task, but still if you want to store the partial records, then you can go with a dereferred modification technique. So what kind of data is going to be saved in dereferred modification technique? Partially committed data of a transaction. Partial information is going to be saved. Immediate modification technique is nothing but this is going to be occurred while the transaction is still active. It is said to be used immediate modification technique. So immediately whatever the transaction you are going to be done, that will be reflected in your database. So if you want to do immediate active transaction, you will go to immediate modification technique. If you want to save only the partial results, then you can go with the dereferred modification technique. These are the two techniques where we are going to save the data in database. Next we have data recovery. So data recovery is nothing but generally in daily life basis, if you lost anything, if you have lost any data, so you can back up it, no? So in the same way, when you have been lost any transaction details, you can take it back with the data recovery. So if there is any system failure or if there is any clashes, so to restore the data, to restore the information, we have data recoveries. So basically these are going to be classified into two parts. Again, whatever we discussed, it has a redo and undo. The same things are going to be happen with the different names. So rolling forward is nothing but redoing the result. So we are going to redo the action once again to get a new value. To get a new value. Rolling back is nothing but if there is any disturbance in the transaction, and if that particular transaction is not successful, we have to maintain the old value. I'm not going to redo it again. I want to abort it there itself and I want my old value. Okay, that is rolling back. So these are the two transitions with different names. Redo, undo. But with different names. Redo here is called as rolling forward. Undo is here is called as rolling back. That's it. And now we are going to see what is log based recovery here. So let's see the theory part first. Logs are the sequence of records that maintain the records of actions performed by a transaction. So log is nothing but we are going to maintain the sequence of actions. So how to so who is modifying the data at which time, what are the actions he made, everything. In log based recovery, log of each transaction is maintained in some stable storage. So where we are going to store this log data? On a stable storage. If there is any failure occurs, it can be recovered from the recovery database. So the log contains the information about the transaction being executed, values that have been modified, and transaction state. Let's go to an example so that it will be clear. So log based recovery is nothing but whatever the database you are going to store. So what are the log records, like who did, when did, and if there is any system failure, you are going to back to it again and you can recover the data by using this log records. అంటే మోడిఫికేషన్స్ నేను చేసినప్పుడు లాగ్ రికార్డ్స్ లేకపోతే నేను దాన్ని మళ్ళీ బ్యాకప్ చేసుకోలేను. If I have a log record, then only I can do it again and I can make my database as a stable thing. So whatever we have discussed up to now, how to start, how to commit, and how to abort, these are the things. And we are also discussed about dereferred data modification, immediate data modification now itself. And let's see the recovery with concurrency transaction. So how to maintain the recovery policies. For to do the recovery policies, we have checkpoints. So first let's go with the theory part. When two transactions are executed in parallel, the logs are interleaved. It would become difficult for the recovery system to return all the logs to the previous point. See what he is going to tell here. Let's take transaction T1, T2, T3, T4. These are the set of transactions. So whenever you are doing it parallelly, there is a chances to the system failure. No, there is a chances where maybe D3 is aborted. If you want to restore it again, what you will do? You will restore. You reached here. That is nothing but you perform T1, T2, T3, T4. You performed all the transactions as per your thought. You performed all. But if you look back, you noticed that T3 is not recorded. Okay, what you will do? You will roll back it again. No? So how we are going to know specifically at T3? By using checkpoints. So what is checkpoint? Checkpoint is nothing but just like your bookmarks. So whenever you are reading a novel, no, you used to put a bookmark. Bookmark is nothing but it points accurate place where you left. As same here, if you have T1, T2, T3, T4, from here logs are not recorded. How you are going to say from here only? How you are specifying it? By using checkpoints. Checkpoint will be there here so that we know that from here there is no records are noted. You can tell like this, or else we can tell in another way. For suppose T1 transaction is completed successfully. Okay, so you are saving. For suppose let's take uploading of T1, T2, T3, T4 results. So T1 is uploaded successfully. T2, T3, T4 are in the action. In the middle, some system failure happen. So some system failure happen. You don't know where you left. T2, T3, T4, this three are in parallelly executing. Suddenly system failure happen and you don't know where you left. How to restart the action again? If you don't have this checkpoint, what you will do? You will restart this operation once again, no? You will restart this operation once again because you don't know where you left over. Network lo manamu 4 transactions చేసేటప్పుడు T1, T2, T3, T4 అనేవి 4 transactions అయితే నేను డౌన్లోడ్ చేస్తున్నప్పుడు ఇన్ ద మిడిల్ ఐ హ్యావ్ సమ్ నెట్వర్క్ ఇష్యూ. నాకు ఎంతవరకు డేటా అప్లోడ్ అయిందో నాకు తెలియదు. ఐ డోంట్ నో హౌ మచ్ డేటా హ్యావ్ బీన్ అప్లోడెడ్ అండ్ ఐ డోంట్ నో వేర్ ఐ లెఫ్ట్. సో to restart the system, to restart the downloading, what you will do? You will do it once again, no? You will start from T1. From starting onwards, you will do it once again. What will happen by that? By that, you are going to waste your time. You are going to waste the memory. And you are in a confusion state. To avoid this, we have checkpoints. So, checkpoint is the place where it is going to tell that up to here, data have been uploaded. So that nothing but T1 have been uploaded successfully. Please start your downloading from T2. It will tell very clearly that you have to start from T2. That is nothing but this is it will do the transaction very fastly and you no need to do it once again because already T1 have been uploaded, that is given by the checkpoint. So you have to upload now only T2, T3, T4 data. No need of uploading T1 once again because you have a clarity by using this checkpoints. So this is how we will use checkpoints. Ante it will clearly tell you where you left over. It will clearly points you that where you are left over in the downloading. Okay. So checkpoints acts like a benchmark. Checkpoints are also called as sync points or saved points. It is a mechanism where all the previous logs are removed from the system and stored permanently in the storage system. So by using this checkpoints, what we are going to do? We are going to do to remove the previous actions, and these actions are going to be stored permanently in your storage system so that the space is going to be free, so you can do the next coming log also. It clears a point before which database management system was in consistent state and all the transactions were committed. So to do the successful committed transactions, we are using this checksums. It is a point of synchronization between the database and the transaction log. So we are going to maintain the data in a sequentially manner. Transaction, we are going to maintain database and the transaction log files synchronously. So we are going to maintain the both data in a way, like with the same phase. It involves operations like writing log records in main memory to secondary storage, writing the modification blocks in the database buffer to store. That is nothing but you are going to store all the log records in the main memory. You are going to save all the records in the main memory permanently, and you are going to give a buffer space where you have to do present present storage. And the checkpoints records contain the identifiers of all transactions that are active at the time of the checkpoints. Okay, so this is about the recovery. So recovery systems. Okay, this is the recovery. Wait a second. So please go through theory part 1. So whatever I explain now, the same thing will be there here in the recovery also. So how to commit, how to start, how to redo the actions, and how to maintain the log. Everything is going to be discussed here.